This is problem number 6 from section 5.6. It asks us to find the area of the region enclosed by the curves x equals 7y squared, x equals 0, and y equals 1. Now, this is another problem where we're not trying to find the area between the x-axis and just some function anymore. We're trying to find the area enclosed by 3 different functions. So we really need to check to see where do these three functions intersect. Well, we know that x equals 0 if we were to graph that. I'm going to kind of graph that in the upper right-hand corner. X equals 0 is just the y-axis. All right, so we can call this x equals 0, which runs up and down. Y equals 1 would be, let's just mark 1 here. Y equals 1 would be this line right there. We know x equals 0 and y equal 1 only cross at y equal 1. Okay, so we know that this is one intersection point. The real question is, where does this function, which if you notice it doesn't say y equals, it says x equals, which means it's a parabola that's sideways. Where does this function intersect x equals 0? And where does this function intersect y equals 1? Well, we can find where they intersect by plugging in 0 for x and solving for y. So we plug in 0 for x, and we say 0 equals 7y squared. We divide by 7, that's 0 equals y squared. We take the square root, we get 0 equals y. So they're saying that this function and this function actually intersect at y equals 0. So they intersect right there. And then let's check to see where x equals y, or x equals 7y squared intersects with y equal 1. Well, we can say that 1 equals 7y squared. Oh, sorry, I plugged that in for x. I meant to say x equals 7 1 squared, right? Because it's y equals 1, we plug it in for y. And that would be x equals 1 squared is 1 times 7 is 7. So they intersect at x equals 7. So if we go out 1, 2, 3, 4, 5, 6, 7, we know that this line, they're going to intersect right there, right? Y equals 1 intersects there. So if it's a sideways parabola, which is what this looks like, this function would look like this. And we're looking for the area enclosed, right? It says enclosed. So x equals 0 is here. Y equals 1 is here. We're looking for this area right in here. That's the area that we want to find. How do we do it? Well, we know that this thing is bounded from x equals 0 to x equals 7. Right? X equals 0 to x equals 7 is our bounds. So our interval would be 0 to 7. We're going to integrate this, and remember, it's if we come back to this function where f of x is greater than or equal to g of x equals 0 we don't have to worry about because that's just an x value, right? That's taken care of in our interval. So we're really worried about a top function and a bottom function. Where our top function is y equals 1, and our bottom function is the x equals 7y squared. So we are really going to want to subtract the two functions. So f of x minus g of x. So we're going to say that the area is going to equal the integral from 0 to 7. And it says y equals 1. So that's 1 minus, and I'm going to solve this for y. So I'm going to say x equals 7y squared. I'm going to divide this by 7, so x over 7 equals y squared. And I'm going to square root this, and we end up with root x over 7 equals y. Now the reason I did this is because I'm only dealing with the positive branch of this curve. So I only need to deal with, instead of saying plus and minus, I only need to deal with the positive version of this function. So I'm going to say minus root x over 7 dx. So now I can actually go through and do my integration. If I integrate this, I should be able to write this as the integral from 0 to 7 of 1 minus, I'm going to split this up to basically root x over root 7 dx. And then I'm going to write this as integral from 0 to 7, 1 minus 1 over root 7 root x dx. And that makes it easier for me to actually do the integration here. So if we go ahead and do that, we're going to say that this is going to equal, if we integrate 1, we end up with x. If we integrate x to the 1, or root x, so x to the 1/2, we add 1, that's x to the 3/2 divided by 3/2. So we end up with x minus 1 over root 7, x to the 3/2 divided by 3/2. And we're evaluating this from 0 to 7. So now we can go ahead and flip and multiply this 3/2. So we're just going to multiply it to the front there. So we end up with x minus 2/3 times 1 over root 7 x to the 3/2. And we're evaluating from 0 to 7. So that's going to give you x minus 2 over 3 root 7 x to the 3/2 from 0 to 7. Let's plug it in. We get 7 minus 2 over 3 root 7, 7 to the 3/2, minus, if we plug in 0, we get 0. So that's going to equal, and let's see, they want this in a simplified fraction. So they want this in fractional form. So let's see, if we're going to do 7 minus, we end up with 7 minus 2 times, if I rewrite this, this would be, remember this is 7 to the 3/2 is the same as root 7 to the 3rd power over 3 root 7, which equals 7 minus, I can cancel one of the root 7s, so we get 2 root 7, and then this would be squared over 3. Oop, not all over 3. Sorry, this should just be over 3. Screwed that up. And then we're going to actually end up with, if we square root 7, right, that's just 7. So we're end up with 7 minus 2 times 7 over 3. Fix that there, you see that there. And then we end up with equals 7 minus 14 over 3, which we can say equals, find a common denominator here, that would be 21 over 3 minus 14 over 3, and that's 7 over 3 for the area in this little enclosed box between these three functions. Hope that helps. I hope that makes sense.